Today's topic is test automation with Docker. And we can surely say that this topic is a very trending one because Docker as a tool is currently very high on demand and popular among users, among those that work in software development projects, and it is very popular for various reasons. One of the reason is that it is highly used for reducing costs in those kind of projects. Emir, my colleague, will actually go through this topic step by step. He will introduce us with some of the basis around the Docker and test automation, and he will go through the demo. But at the end, we will have a Q&A session, which will last around 20 to 30 minutes. I would kindly ask you all, if you have any questions, please add them into the comment section, and at the Q&A section, at the Q&A part, we will go through those questions one by one and try to address them as much as possible. Okay, so this session will be recorded. So I hope that's fine with everyone. And I think Emir can now start with this interesting topic. Emir, good luck.
Okay, thank you. Thank you very much for a nice introduction. So as Ayla already said, my name is Emir Hodzic. I'm here at System Verification. I have 4 years in experience in test automation. And recently I started going a little bit into DevOps, and that's when I started playing around with Docker and found how great the tool is and how it can be used in test automation. So before further ado, let's go on with the motivation why I actually started going into DevOps. So when you look at the QA career path, you usually start as a manual tester. You started testing manually for some company, finding bugs, learning software development lifecycle, how everything works, and little by little, at least that's my story, little by little you start going into one of two possible directions. Either you go to more business direction where you become requirements engineer and later on you can become business analyst, or you go into more technical side where you can become test automation engineer. And then what? That was my question as well, since I found myself that all the paradigms and and different things you can do with test automation, this usual setup of testing web applications that most of us do using Selenium or different tools for API testing, you start questioning where you can go. So one of the ways you can go is to become an automation engineer. So you are not only automating tests, but you are generally automating stuff. So one of the paths that I found very interesting is infrastructure automation engineer, or sometimes referred as DevOps engineer, which is, according to all the documentation and academic material that you can find, it's not a valid term. So DevOps is defined as a culture which is defined as a superior to current silo culture that we have. We will see more in the next slides. So today we will have a small theoretical part where we will see where the Docker is in the DevOps. We will see what is DevOps and what are its approach in software development lifecycle. We will see some DevOps tools and techniques, and in this part we'll see where the Docker fits in all of these. We will talk about Docker and containerization. What is it? How it came to be? And we will see what role does the Docker play in test automation. After all of this, which will, I hope, not last too much, we will have a few different demos where you will see everything in action, and I will share with you all the code that I have publicly on my GitHub, where you can start playing around from some basic test automation project that already has all the things that you need for starting with Docker. So what is DevOps? As a lot of you probably know, it is coined from two words, development and operations. So it came out of Agile and frustration with Agile, because some of the problems that Agile tried to solve, it couldn't solve. So Patrick Debois tried to patch this frustration with DevOps, and the term was coined in 2009. So it's not really something old, and a lot of us don't really understand what is it about. So in short, it is a culture and practice that combines dev and ops to shorten software development lifecycle and in the same time keep the high quality. So the problem with this is that there are different goals of developers and operations. Developers want speed, they want to release fast, to release something new as fast as possible, while operations, if something is down, the first person you go is probably the person who is taking care of the servers. And it was seen that these opposing goals are good, but in some situations they are not. And also for me as a QA, I experienced a lot of strain because of this, where you get the code to test in last 2 days and you have to go through everything and to sign off as fast as you can. And it leads to a lot of frustration. So in these traditional silos, we have devs that write code, they finish it, they have some code freeze, and they give it to QA, to some test environment. We test it, find some bugs, and they have to redo some stuff again. And back and forth, back and forth. After some time, the code is nice in our eyes, and we say, okay, we give it a sign off. After this, there is another wall where we have to say, okay, everything's fine, this can go to the production. Then operations takes this code, they try to deploy it, and suddenly some production issue happens or production completely fails. So business then comes in, because they come when something is on fire, and they try to find out where's the problem. So operations would say it's not up to us, everything was working until this last deployment, but dev would say it was working on my machine and it was working in test environment. What I don't see where's the problem. So with this core problem comes the main benefit of DevOps. So with DevOps culture, it is about collaboration between dev and ops. There's no finger pointing, they did this, we did this, it's their fault, and so on. So speed and stability should go hand in hand. And the goal is for everyone to have as fast time to market as possible, to have a few production failures, because production failures always happen, but to have immediate recovery from failures when they happen. So when we look at the DevOps practices and DevOps tools, they include a lot of things. DevOps practices are kind of fine. They have a finite number of DevOps practices. When it comes to DevOps tools, there is, it's not that there is infinite number of them, but there is a huge number of them. So for each of these DevOps practices, like continuous integration, continuous deployment, infrastructure as a code, configuration management, orchestration, monitoring, you have different tools. Some of these tools are mainly for the specific DevOps practice, but they usually cover different DevOps practices together. You can see that Docker is in the place of infrastructure as a code. And what's interesting about Docker is that it's not only infrastructure as a code, but it plays a crucial tool in these other different tools. So, for example, you have a great, the Kubernetes can't work without Docker. You have a great support on Azure DevOps for Docker, and so on. So Docker plays kind of crucial role in the explosion of DevOps and demand for people who do DevOps. So one other reason for DevOps and its explosion is cloud. And we can't talk about DevOps without the cloud. And all these major cloud providers have great support for Docker, at least. Uh, and they, in some way, they set the standards for how things should be done. So at the end, in the end, we will see the example on Microsoft Azure and how we can incorporate our tests, pack them in the Docker, and have them executed on Microsoft Azure. So now, when we have a small overview of the DevOps, we will see what is actually a Docker, what's the idea behind it. So when we come back to the real world and check what is a Docker, it's a containerization tool. And when we look in the real world, the containers were the main reason for the trade boom in the 20th century. So they created standards for sending goods with ships, trains, and trucks. They speeded up the delivery of goods, increased the amount of goods that can be transported, and they increase the safety of goods as well, because you have to pack everything together inside one container before delivering it to the shipyard where it's going to be transported on the ship. So all these reasons, they take them literally and apply them to the virtual world of containers. So containers in the virtual world are kind of a small revolution in IT. We don't have to manually transport the code from my machine to test environment to some production environment, but we pack them in some containers that are standardized. All these different environments know how to work with them, and we send them on their way. So there's only one standardized way. uh, there are more coming on these days, but Docker is still the king of all of them, and it's very fast and intuitive when you start using it. So now, before any further ado, let's go to the demo, and we will see through the demo how we can run the tests inside the container, how we can skip the configuration of web drivers. So the big thing, it's not a very huge hassle to configure these web drivers, but with Docker, it's even less. And I want to point out this last point where we want to make sure to have the same resolution and all the other things on our remote machine where we are executing tests and locally, because sometimes I have a personal experience where I spend like 2 days trying to figure out why my test is failing. Actually, few of them are failing on a remote machine and passing locally. And finally, I realized that the resolution was different. This is not going to happen with Docker because the resolution and everything else is the same. So let us go to the Visual Studio. First, I want to show you here, just a second. Here you can find on Emiride/test automation base. You can find this repository that I'm going to explain upon this, and all the code that is going to be presented here is going to be available here. So I have it here in Visual Studio, and if you look at the code, it has 3 different projects: Demo Core, which handles Selenium WebDriver and other extensions, elements, and stuff. Demo Pages, where I map the pages, and Tests, where the actual tests are written. So the test itself is very simple. It takes this site called automationpractice.com, which is very nice for practicing your test automation skills. So I made use of it, and the test itself is very simple. It just goes to home page, click on sign in, it registers with the sample email, and on the next page, I verify that this email is visible on the second page, so I don't have to rewrite it. So the test itself is very simple, and we can run it in multiple ways. So now, when it comes to Docker, we can run here in web execution tool.cs. I instantiated my driver, and I have several ways of instantiating. Either you can run a local version of Chrome driver. If you specify Chrome in this static configuration, I specified Docker, or you can have Docker. So for Docker, I need to specify a remote web driver. And in .NET, for the remote web driver, you don't have to specify any ports or URLs. You have to if it's out of the usual setup, but for me, it's very usual setup where I'm using localhost. And if you hover over it, you can see that it initializes a new instance of remote web driver, and the constructor defaults to proxy localhost 4444. And so now we need to have some local server that will have a driver in its own on this port, so we can connect to it and run the tests there. So if I try to run tests now, since I don't have anything, it will fail. And let's not wait until it fails. Believe me that it's going to fail. And in the meantime, we are going to go and check the PowerShell. So also I want to mention the way to install the Docker. The Docker is installed as any other app, at least on Windows, where you can download Docker Desktop. On Mac, it is the same. You download Docker Desktop, you install it. Just beware that you might need to go to the BIOS to enable something called Hyper-V for Intel processors. And you have to have Windows 10 Enterprise or Professional. So if you don't have that, you will have to have few workarounds. Where is another tool called Docker Toolbox, which you have to install. For Linux, it's pretty straightforward as anything with Linux. So you just install it from the command line from your repository for any flavor of Linux you use. So when you have Docker Desktop, when you run it, you have this small icon. I don't know if you can see it, but it says Docker Desktop is running. So Docker in itself is kind of a virtualization tool that is very efficient and works on all of these different platforms. And for any thing that we download, it packs it inside of a container. So we have something called Docker Hub. Docker Hub is like a repository of all different pre-packed applications inside of the containers. So these pre-packed applications inside of the containers are called images. So you can you can see images as kind of classes, while containers are like objects. So you instantiate the container out of the predefined image. So what we need is to look for Selenium, and Selenium as organization has its own different images here, and it is very easy to start any of these. And the way we can do it is we can go to PowerShell. First, we can type Docker to check if we have Docker. So, I mistype it. So it's not Docker, but Docker. And if you don't have anything in red, at least in PowerShell, you are fine. So the way we do it, we say Docker run, and then we specify the image we want. So I want Selenium standalone Chrome. I copy this, go back to PowerShell, I paste it here. Okay, and the thing is that I need some way to communicate with my image. And the way to do that is to expose the port. If you look at the documentation of this one, which you can find here on this link on Selenium, you will find that by default, these images expose port 4444. So as you could see in our code, the remote web driver by default goes to port 4444. So we don't need to configure anything else, but I want to do something else. I want a specific version of Chrome, debug version, which is not good for production environments, but for local and testing environments, it's fine. So debug version exposes two ports. It exposes port 4444 and 5900. We will see later why we need that. So in order to expose ports, we need to say P and then say 4444 maps to 4444. What this means is that this container exposes this port, and we want to map this port to the same port on our local computer. So when I say this, what's going to happen, it's going to download, just a second, it's going to download, so failed port is already allocated. So let me use some different port. I want 4443, let's say. But I'll need to change here as well. This is going to be a little bit complicated. So let me. Okay. Now I have a little bit of problem. I have a port that is already allocated. So I need to find a way to kill it. Docker system prune A. This way I can clear everything from the Docker. So probably while I was playing around before this demo, I ran something that took my port. So now it's still allocated. Let me go the harder way then. Let us change the remote web driver and change the port. Since I don't know how to do that, let me Google it out. Change port of remote web driver in Selenium, in .NET Core, actually. I need .NET Core Selenium. Okay. Or it's maybe easier to clear the port on Windows machine. Clear specific port on Windows machine. So, okay, in CMD, I need port number. I need 4444. So I need to kill probably, yes, I need to kill this PID. So some process took this port and I need to kill it in order to continue. Okay, and now can I run it? So it's not this process. Let's try 22340. And let's try 22020. Okay, let's try this now. Port is already allocated.
We have one question. Perhaps if there is any existing container that is configured to use that specific port.
No, I don't have anything. If you look at the Docker PSA, I have these that I started. Let me try Docker stop and then B47 ADC. And let's stop all of these docker PSA. And this last one is running F97 docker stop. In the meantime, these are the containers that are running on my computer. And the last one, it says it's up for 3 minutes. So this, it seems that this is the one. Let me stop it. Okay, I think now it's okay. Thanks for the guy who took notice of it. So if I say now docker run, okay, it's there. Selenium server is up and running on port 4444. So I have Selenium server now running, and for the test that failed, if I go right click and run, it's gonna fail because I added here, comma, run. As you can see, sometimes these ports can lead to a little bit of hassle around, and probably my Docker system prune didn't work because it should delete everything, but it didn't. So it doesn't matter. What this is going to do, it's going to connect to the container that is running. We just created it, and it's running on port 4444. We expose that port to the local machine, and the test is running. The problem is we don't see where is the test. So that's why we took this debug version, which exposes another port through which we can connect another application called VNC Viewer and actually see what's going on inside. So now, instead of doing this, let me stop and let me again locker PS see what's running, if there is anything else. Yes, let me stop it. Stop A95. And instead of docker run P444, I will say docker run P5900 colon 5900. And now we have, I made some, P dash P. So now I have 2 ports exposed from this container. So now when I run the test, first let me connect to the VNC Viewer. It's a tool that's available for all the possible operating systems. You can find it online. And here we have to specify localhost 5900. And we can give it a name, Chrome driver local. And if we try to connect, it will ask us for password. And if you look up the documentation, you can see the default password is secret. And now we are connected to the container. Now, if we run the test, we can see that it will be opened inside the container, and we can see what's going on inside the container, and we can see the test running. So this is the simplest way of running the Docker. Now you probably are going to say, who is going to remember all of these different things? So once you remember them, believe me, you will always know them, but there is easier way, which I'm going to show you now. So with this approach, we have to remember this whole line, what's going on. We had to say docker run, then show the ports, and then show which image we want downloaded. So the other way of doing it is with Docker Compose files. So ideally with Docker Compose, we have Docker Compose up and everything should be ready. We don't have to do anything. So we need to write Docker Compose file. I have it written here. The first one, this Docker Compose direct, when you look at the repository, it's the easiest one. And the only thing is that you have to specify the version, services that we are going to use. This is completely up to you how you are going to name your services, and the image where it is, and the ports that are going to be exposed. This is in a YAML file. YAML is a special language usually written for these code as infrastructure as a code tools. You will find it at different cloud platforms as well as for Docker Compose. So instead of writing this long line, we can just say, first, let me again clear everything, Docker PS, if it's running, and say Docker stop. So each container has its container ID. You don't have to specify the whole ID, just few first letters. So it's 21E14, so on. I stop it. And then since I have to move to the folder where my Docker Compose is, so it's easier to write commands. So here it is. It is Docker Compose direct. So what I need to do, I need to say docker-compose, and ideally would say just up. If the name of your file is just docker-compose.yaml, if the name of file is different, then you have to specify the name of the file, which you can do with -- file, and then what's the name of the file. So it's docker compose direct YAML, and then I say up. When I do that, it will just read everything from there and do the same thing. So just say docker compose, specify the file, and say up, and it will do the same thing. Selenium server is up and running on port 4444. So basically that's it. Why is this good? It's good because someone who comes to your office, some new team member, he only needs to install Docker, and you can have Docker Compose in your solution. He just specified Docker Compose up, and everything is up and running. He can run his tests already. And also you can have it locally, but also if your tests are running inside of the containers, which is very good, we will see later, the configuration is the same. So you can be sure that everything is the same on your local machine and on the server. So let us go back to the presentation and see how this actually looks. So we have a operating system. Underneath, we have Docker installed on our operating system, and inside of the Docker, we have Chrome driver image, which exposes two ports, 4444, which we map to 4444 on the operating system, and 5900. So we connect to 5900 via VNC viewer and to 4444 from our code with Selenium remote driver. So next thing we can do is we can run our tests in Selenium Grid. So if anyone used Selenium Grid, you know how complicated it can become to set it up and to connect all the different nodes to it. However, there is easier way with Docker, where you just bring up your Selenium Grid, connect Chrome driver nodes to it, and you don't have to specify any IPs or different. It will be connected just by the name of them to Selenium Grid. We will connect to one of these Chrome drivers through the port, and we will connect to the Selenium Grid instead of connecting directly to the nodes through this port 4444. We will do it through Docker Compose file again. This time, Docker Compose file is a little bit more complicated. So we have three different services. So we have Selenium Hub, which is going to take the image from the website here from Selenium. There is a Selenium Hub image, and expose port 4444. We will have one Chrome image that is going to spin up after this one. That's why we said depends on. And the host that we defined, we just defined the same name as we defined here for this service, and it will know where to connect. Hub port is 4444, and we are exposing this Chrome to be able to connect to 5900, and also this one to connect on 5901 through VNC viewer. So now let's go back to the PowerShell. We need to make sure that we stopped everything. So instead of Docker Compose direct YAML, we'll say Docker Compose Hub, because that's the name of our file. And I will add another flag called remove orphans, which will make sure that nothing else is running. So now it's pulling Selenium Hub from the Selenium. Some of parts of that hub already exist here. It's spinning everything up. And in a minute, it's registered Selenium Hub node to the Selenium Hub. And now, if we go back and run the test, first let us check if everything is working correctly. So we can go to localhost 4444/grid /console to see if everything's fine. So we can see that we have Selenium grid on this port, and we have two different containers connected to it. Each container is running is capable of running only one test. You can have numerous different configurations for this, but this is this is a simple one. So if we go right click and run, we will see that it chooses one of these two nodes to run the test on it, and we can see it by it will be grayed out. Okay, it's running on this one, and we can connect to VNC viewer. We map to the same port, so we can connect with the same viewer, and here it is. The test is running inside the container. So basically, that's it when it comes to this part. So what else here needs to be said is that you can do cross-browser testing. You can connect Firefox and Opera. However, as of time speaking, you can't connect Edge and Safari. Safari probably not in the future, but Edge is in development of being created as a node for Selenium Grid inside of the container. So as we said, this is the kind of schema that we have here. So we connected to Chrome driver and have seen that is running through Selenium Grid on the inside of container. So next thing that we can do is that we can run tests in Grid in Azure pipeline. So this is going to be a little bit different. Now we are not going to have a code locally in our computer. I'm sorry. But we are going to pack our code inside container as well. So we will have one container where all the code will be, and that container, from that container, all the tests will be sent to the Selenium Grid, which in turn will send a test to each node. So the setup is the same. You have Docker Compose, where you specify all the services, but this time we have something called Docker file, which we will see in a minute. And why is this a good solution? In general, it is a cheaper solution because this way you can, before when I started working, what we did was we have a physical machine on which we run our tests. So even if we have Selenium, we would have a Selenium Grid on one machine, and we would connect these different machines to this machine. And basically, Selenium Grid would run tests on different machines, physical machines, so we can speed up all the tests. I mean, you can from the first sentence, you can see this is not a cheap solution, especially if you are renting those machines. So these days, there's another way, a little cheaper, but still not like Docker, where you can host your virtual machines in cloud and then connect to them. But with Docker, you can run tests straight from the pipeline. So basically, you create the pipeline, and inside of the pipeline, you spin up everything in Docker, run the tests, get the results, and export those results to the place you like. So it's a lot cheaper solution. And we will see it now in Azure pipeline, how it's done. So let's get back to the code and see what's in our Docker Compose pipeline. So as you can see, some parts are the same. We have two services that we already used. We have Selenium Hub, which pulls this image. We have Chrome, which pulls this image. But then we have demo tests, which doesn't specify any image. So, but it has a new command called build. So what does this build do? It actually builds an image out of the Docker file. And you can, basically, if we want to be more specific, we would specify Docker file, but by default, Docker file is named Docker file. As you can see here, I don't know if you can see, but I have a file called Docker file, and it has this content. So if I look at the structure of my folder, I have in the same folder, I have Docker file and these Docker compose files. So this build here, and when I say dot, it means build it from the current context. So current context, this Docker compose is in the same folder as our Docker file. So it will look for the file named Docker file and build our image from that file. So if our Docker file is in some different folder, we would say slash name the folder, and it would specify. If our Docker file has different name, we would need another argument called Docker file, and we would just give it a name, whatever the name is. So that way it can find from where it's going to build the image. So far, our images were ready-made. So, and all these images, if you look them on Docker Hub, they are created by Docker files, but hosted on Docker Hub, as Docker Hub is like a repository for all different images. So here we have a Docker file. What does this Docker file do? It basically starts building our image from some parent image. The first line is actually specifying its parent image. That's the terminology from Docker. So the first, if you want to build like from scratch, the first Docker image that's going to be your parent is called Scratch. And if you want to do something from the bare minimum of Linux with the base kernel, you will say from scratch and then start writing your commands. So here we are starting from already existing image provided by Microsoft, which is, you can find it also as we found for Selenium, you can find for Microsoft all these different images, what they do, what they have, why any of them we need, and start building on them. So work directory is the directory inside the image. If you go inside of the container, check the content, with this work directory, we specify in which folder inside of this image we want our code to reside. So we want this one to be in /crc. So we copy these CS_proj file because we want to restore all the NuGet packages and stuff, so they can be in the same CRC file. And then after we do that, we copy everything. We could copy everything and then do .NET Restore. However, whenever you change, for example, if you change something here, when the Docker starts running and you already built your image, it's not going to rerun these ones. It's only going to rerun the ones after the change. So since this is somewhat expensive operation of restoring, we don't want it to be run every time. So this means if we change some code, it's not going to restore every time. It's just going to copy the content of the code. And the last command is CMD, which basically means command. It is the command that is going to be default when we instantiate this image, when we create the container. So when the container is first created, it is immediately going to run .NET test. So what is .NET test? In this specific scenario, if we want to run tests from the command line, basically when we go here and go right click, run, we run all the tests. In the same way, we can say .NET test, and it will run the test, all the tests inside the solution, because we are in the root folder of our solution, and in this folder is a solution file. So without any further talk, let us run some commands. First, let me check if I have anything running. Docker, not .NET. Okay, I don't have anything, but just to be sure, I will use another command, docker compose down. It will make sure that everything that was up is now down. So some of them were still up, so they're now down. And now we can say docker compose, we need to specify the file, which is now pipeline. and we want to say up, and let's just be sure and remove orphans. So now it's building demo tests. It's downloading everything. So basically it needs to download this image from Microsoft in order to build upon it. So there is another command. So you can see we have two commands. We have Docker and Docker Compose. On Linux, these are two different command line tools. In Windows, they are as well. However, you install all of them by just installing Docker Desktop. So you have access to Docker Compose as well. So when you go Docker run, as we did before, we set Docker run and then specify the ports and what image we want to pull. It pulls automatically. You can also just say Docker pull and pull everything you need without running it. So I could do it before, but I did Docker system prune, so it cleaned everything when we had that problem with the port being being busy. So now it's trying to restore all the projects with .NET Restore. As you can see, it has the steps, and these are the same steps. It copied everything. And as I said, .NET Restore is very expensive command. And now it's up and running. And not only that, everything is in containers now. And as you can see, since I had the command .NET test, now our container is starting with that command, and the command is starting the tests. And since we have everything in the code that will connect to the ports and stuff, it's going to connect to the Selenium grid, and then the Selenium grid is going to execute to on the Chrome driver. So we can do the same thing on Azure. So let's see how we can do that. We can go to the Visual Studio, to the Chrome, and let me go to the Azure. Okay, I'm already logged in. So just take one note. You have to have a profile on portal.azure.com. Since you have a free version of Azure DevOps for 30 days, I made use of that, and you can play around with it, create virtual machines. You have basically $200 on your expose to do anything you want. So I did that, and here I have a code the same as on GitHub. And here, if I go to pipelines, okay, let me delete this one just to be sure to start from the beginning. Okay, now I don't have any pipelines, and I need to create a pipeline. So here you have our code is here. You can also, you don't have to copy code. You can take it from GitHub directly. It's here, so I'm using this one. I need to select it. So now, since I already did this, it created for me a specific file that is, again, YAML file. It's called azure-pipelines.yaml. And it instructs Azure DevOps in which way to run all of these containers, in which way to create the pipeline. So if you are doing this first time, you can either learn the syntax, which I didn't, but I use their assistant, which is great. And you can just type Docker here and find that there is a Docker Compose. So this Docker Compose, if we specify it, we need to specify what we want. So what's the name of Docker Compose file? What is the action that we want to do? What is the command? So here I would say it's up, as we did Docker Compose up, this file I specify up there. And also I did one other thing. I set abort on container exit. In the previous version of Docker, this was by the default behavior. Now in this version, in newer version of Docker, it's not default. So this means that if one container exits, everything that was run through this Docker Compose needs to exit. Why I did that? Because when we run Docker Compose up and our tests finish, Selenium Grid and nodes will still be running, so our pipeline will never end. But one container will exit. It's a container with our tests. And we want, since that container will exit, we want all the other containers to exit. So with this, we just need to click run. And one more thing I want to mention is that these steps you need to edit. This tool will provide you with the task, but you need to say steps, colon, and then add the task. This will basically generate the code here when you fill up everything on in this helper. It will generate the code similar to this. This is basically my Azure subscription. So if I say run, it's creating a pipeline. And yeah, I need to permit it. So now it's going to run. And what I expect from it is to behave the same way as it behaved locally. So now what it's going to do, what we have seen locally is that, okay, this test run successful, total tests 1, passed 1, total time 31 seconds. So I want to see everything to be the same. Even the log should be same. So if I look back, you can see some basic info on what's being done. This is, I think, running on Ubuntu, so you can see that it's cross-compatible. If you are using Windows, you can run everything. You can create these Docker files and Docker Compose files. And if your friend doesn't want to use Windows for some reason, he can do everything the same on Linux or Mac OS. So this is running on Ubuntu 16, I think, by default. There is some information about that somewhere that I've seen. Yeah, but so basically, it's not only that you are consistent in the cloud and your local machine, but you are consistent across multiple different operating systems. So this is going to take some time as well. It's actually faster than my local machine. And it's going to run the tests. So now with the framework that I provided, you can add your own loggers, you can add your own reporting system. This is not here, this is only the skeleton of the project with page object pattern. You can run multiple tests parallelly, and you can use this in any way you like. So you don't have to reference back to this. You can fork, you can clone, create your own GitHub repository, whatever you like. Let's go back and see if the test is finished. Just a second, I have here. Okay, post job. Let's see what happened there. So it says total tests 1, passed 1. So now we created our pipeline, and everything is running inside of the pipeline, inside of the Azure DevOps. We don't have to go and connect our Selenium Grid to other machines. So I hope that this was not hard to understand. And in case someone didn't, let's see the graph, how it works. The graph is even simpler than the previous one, since everything is running in Docker now. And here we have our test code in one container that is communicating with Selenium Grid through port 444. And the Selenium Grid is communicating with other Chrome driver nodes. And I exposed this port, but we didn't look at it on Chrome driver through port 5900 to the operating system. So only one port is exposed to the operating system, and the test code is running with the CMD, the last CMD that we defined. Thank you for listening. So I hope that that you have questions. I hope that I was easy to understand, that you can have at least some basic knowledge on why is this helpful and why is this money and time saving thing.
Okay, thank you, Emir, for this lovely overview and presentation of yours. First question that I have for you is, can you elaborate more on why you copy the remaining files after you restore? I'm not sure I understand the explanation, so can you brief us on that part perhaps more?
Okay, so I hope it's not Corona. So basically, if you first let me show you one other thing you can do, which is probably show me as a little less competent maybe, uh, because I didn't write this on my own. I did modify it on my own. However, you have an option here to say on any project you have, you can go to the project, at least in Visual Studio, and you can say add Docker support, where you can say Linux. I want that's my target OS, because you have Windows containers as well. And it will create Docker file for me. And this is how it looks. Since I don't need all of this, I deleted some stuff and simplified some stuff. But I just want to make you aware of it, that it exists. So you can build or reduce based on this. Okay. So why I did that is because for anything we change inside of our code, and if we want each time to run everything inside of the containers, so we want the code to be inside of container, and uh, we want everything else to be inside of the containers. So if we change some code, it's not going to do restore again, because we didn't change csproj file. However, if we add a new file or class or something, inevitably csproj file will be changed. So since nothing in this file will be changed, these files will be changed. This command will not be executed. Uh, since this is expensive command, we don't want to restore every time. We want only if something in these is changed. This can be further optimized, but for me, it was enough. So if we change something here, for example, in base page, I don't know, add some space, Control S, and if I run again, Docker Compose pipeline, which is building my tests from Docker file, it is going to take a look at the Docker file, see, aha, here nothing changed, here nothing changed, here nothing changed. So I don't have to run this. But here, some file changed a little bit, so I have to copy everything again, except these things. And since I restored everything and stuff like that, I only have to copy everything. In itself, it's a little bit expensive, but not that much. It can be further optimized by including some Git tool for comparing files and not to copy files that are not changed and so on. But for me, this was enough. I hope that this answers the question.
Okay. I hope you can see me all. Hello there. So do we need to expose port for only WebDriver images?
So we can expose ports that have some ports that are exposable. So if we have some containers that is not exposing any ports, for example, my project is not exposing any ports. So if it's running inside of this container, there is no way for me to access it from the operating system when it is running to access this container, because I don't, in the code itself, I didn't say, okay, this is available on this port and so on. So I can't really attach to this container when it's running. I can go through Docker and go inside the container and see what's inside, but I can't see from the outside world, from the operating system. So this port for us is for the container to be available to the outside world. If you want the port to be only available inside the Docker, there's another command that you can use. So we could easily, instead of saying ports in this, not in this one, but in pipeline, we could easily say for Selenium Hub, instead of ports, we could say expose and just say which port we want to expose. This will do the same thing. And this is maybe even more secure because here this graph will change in a way that this port will not be available to the operating system. It will only be available to the other containers inside of the Docker. So if since Selenium Grid, if you look at the documentation, is giving us inside of the documentation Docker Hub. If we look at the documentation of the Selenium, we can see that the ports that are there are the ones that we used. So basically, I read the documentation, have seen which ports I should connect to, and did that. So for each of these, you have every image is created by someone, so you have to read how that image can be used. I hope that answers the question.
Do you need the license to create more than one node to run multiple tests, or you can create all the nodes you want?
When it comes to Selenium Grid, I'm not aware that there is a need for a license, especially for running everything inside the Docker. And actually here inside of the second demo, I think, Docker Compose Hub, we had uh, 2 Chrome images. Just a second. We had 2 Chrome images. So basically we had 2 nodes running inside of them. You could specify on each node more web drivers as well. So I don't think that there is a need for a license in order to do that. If you want to run it inside of a pipeline, you have to create account there on Azure DevOps. When it comes to Azure DevOps, I used GitLab as well. They have a free versions as well. You use some shared builders, which are a little bit slower. But I didn't use AVS and Google Cloud. So for Azure, you have to create, but you have 30 days trial, $200 to play around. If you are a student, there are special packages that you can use. I don't know, for 1 year, 2 years, and so on. And definitely make use of that. I did when I was a student.
Is it possible to do the same setup with the Java Selenium code as well?
Yeah, this is completely completely independent of the code. So that's why we don't have to specify almost anything inside the code. We can specify everything inside these Docker files. Even you can even specify environment variables here. I don't know if I did that somewhere. Yeah, here. For example, for demo tests, I specified environment variable, Selenium grid URL, and inside the Docker, it behaves the same way it behaves as in your local machine. So this is completely applicable to any operating system. The only thing you need to take care of is the way you connect to remote WebDriver. Inside of .NET Core, it has a default constructor that connects to this port 4444. I suppose since Selenium is one big organization, it did everything the same for all the other bindings for different languages.
Could you run tests in parallel on multiple browsers using Selenium Grid with Docker? And do you have any examples of that?
Let me create an example, just a second. So I have here one test. Let me create another, the same test. So I'm sorry for creating the same test. Actually, let's just copy and paste this file and change the name, registration test 2. So the infrastructure of the code is that if you have in one class, you have multiple tests in methods, these will run sequentially. But for different classes, they will run parallel. So let me just change the name and change the name. I don't know if I have to change this one. Let me just build again. Okay, now I have 2 tests here, and let me spin up the Docker Compose hub. Docker Compose down. I changed something in the code, just a second. Docker Compose pipeline, everything fine. Hub, everything fine. Direct, everything fine. Docker Compose file, I want Docker Compose hub. I want up, remove orphans. So now we are going to spin everything up again. Okay, and let's go to the here and check if it's on localhost grid console. Here we have again the same configuration. I didn't want to do that. And now let's run the tests. Run. So, I mean, it mainly depends on the way you create your framework. If it's not execute, if it doesn't have the option to execute multiple tests, it's not going to execute multiple tests in the parallel. Okay, so now they are both running, and if I refresh here, you can see that both of them are running. So we can connect with VNC Viewer to both of them. I don't know which we did expose to the outside environment. So 5901 and 5900. Let me check on VNC Viewer. This is 5900. It probably finished, right? Yeah. So basically, you can run parallelly, and you can, in this specific framework, I specified here number of threads to be 3. You can do however you like, and the magic of web execution tool will take care of the rest. So the short answer is yes.
Okay, thank you for that great example. Another question is, in which cases you would not recommend using Docker?
If you are just starting with test automation and you are just learning things, take your time and learn test automation first and then go to Docker. Because in my opinion, I mean, that's my personal story, to be honest, because I started with software developer, then went to QA test automation, and then I started becoming interested in these DevOps tools. So if you want to follow that path, you are not going to start with Docker. Because you want to learn what is a driver, how it works, how you connect to it, and so on. So this is going to make you a little bit lazy. But if you are working on enterprise application, your stakeholders tell you that they want to save some money, they don't want to use multiple machines, you can go with the Docker.
Thank you. How do you combine reports running on various containers? Any examples of that?
So even if they are running on different containers, I didn't do the reporting here, but the way you can do the reporting is that either you can spit out the file with the report that will contain all the report in some JSON or HTML file or any way you like. And it will be for most of the cloud platforms, it will be in something called artifacts. So I don't have it here because I didn't set it up that way. I just wanted to check the logs there. But for other guys in the company that are working on different projects, they are able to connect this pipeline and the results in the pipeline, to parse them and to be shown inside of the test plans, to actually see which tests have passed, which test did not pass. I didn't want to do all of this because it's only this test plans is available there for 30 days. After that, I will not be able to see this. But also I can't show you the setup of my clients. So on this, it is possible. It is not hard, but I don't think that I can do it right now. So you will need depending on your needs, you will need a different configuration for reporting. The reporting in itself is like a whole whole level of doing things in test automation. You you have to have good reporting, which I don't have in this skeleton project.
Selenium Grid is supporting only Linux containers. Is there any good way to run Selenium driver on Windows container?
To be honest, I didn't try that. What I've read about Windows containers, and I I was a little bit frustrated about existence of Windows containers, because when you read about containerization, it has its own standards, and then there is only one type, and then suddenly there is Windows containers. And then I found that these Windows containers are used for people that are strictly locked inside of Windows, that have some software that was written strictly for Windows. And you can, for example, if you write something in .NET Framework, there is no way you can run it Linux, since .NET Framework is proprietary. And to be honest, I didn't try running it on Windows containers. For anyone who is starting and doesn't have to use Windows containers, don't.
Okay. Is there a limit on running the tests in parallel, or I can run as many different tests I want in parallel?
There is a limit of a machine, physically, how much machine can handle. So uh, I don't know this out of the box machine here on the pipelines, what is the configuration of that machine, but basically, if you have, you definitely, the the only limit is your hardware. There is no software limit on the number of nodes and number of machines on which you can run. In terms of Selenium Grid, I'm not sure what's the limit. I have never, in my experience, I have never touched the limit to say, okay, here's the limit, but these nodes are not running because of this limit. It never happened.
Thank you. Would you let us know about some of the challenges you faced when working in Docker?
So the challenges, as you could see in the mistake I made, are sometimes something happens that you don't know why. For example, I ran Docker compose prune, and Docker system prune, it should delete everything from the Docker that I have with this flag A, meaning all, but it didn't. And the even though Docker desktop and the Docker themselves is very easy to set up, it was easy for me. Sometimes when I was installing on my other machine, I encountered some problems that were very hard to solve. So you have to go through different forums to check what's going on, why this error is showing up, and so on. So when things go wrong, they can go really wrong. And that is the biggest challenge. Also, uh, please try to understand the concept behind it. So it's on Windows, at least, it's a virtualization. You have these small packed containers that are running on some minimal Linux kernel, and they are completely independent of your machine. The only way to connect to them is through ports. There is also something called volumes, but you can read more about that online, where you can map the storage of the container locally in your machine and play around with that. So the challenge is this sometimes unexpected behavior from the Docker.
Thank you. Can we use Docker to mount a web page to test, or the web needs to be hosted outside the Docker?
You can definitely mount the web page as well, or any web application. And the name of this webinar is Docker in Test Automation, because Docker in Test Automation was later. We started it using later, after our dev colleagues, because dev was using it before us, and they packed the application. A lot of applications are packed today in Docker containers that are run on the cloud. So it is definitely possible, and you will have to specify Docker file, how that application is going to be built. And if you have some database, you need to connect to it either in different container or on that machine or a different machine. So you need to configure a little bit, but definitely it's possible, and you should try it if you want to go further and really master the Docker.
Thank you, Emir, for these nice answers and lovely overview. Are there any further questions? Please post them in the chat if you have anything else that you would like Emir to address. Perhaps, Emir, you could let us know about some of the recommendations, when to start implementing Docker in test automation, how to start, what is the first step, and so on.
So one of the ways is that you can use my project to start with it, playing around. It's very easy. Basically, you have seen everything. The way you can use it, you can rename the solution. But if you want to start from the ground up, I would say try with the some database server. For example, Postgres. So I tried with it. I was working on some project, and I needed to set up local database to install Postgres in order to play around with it. And I know that when you want to install some database server, there is a lot of pain around that. You have a lot of things that you need to configure. And for example, if you if you want to install Postgres through the Docker, you say Docker run Postgres. If you have a specific version of Postgres, you specify colon that version. So now this will pull the Postgres, and I will have Postgres inside of the container that I can connect to. So this is the simplest example that you can go through, and you can use it in your daily life by installing some tools that you don't want to install on your local computer because you have to change numerous files inside your system. So next time you do something is definitely different. You can't install some other program and so on. So in this way, you can save yourself and have this specific database inside of the container, and just expose some port, and it's going to work the same as you install it on on your local machine. But the only thing is not going to intervene with your system files. And also some of the classic example are some web applications. I don't know, I worked with Angular a little bit, building Angular applications inside Docker, and also Nginx as a server. So you can create any architecture you imagine, you can create through the Docker. Uh, so the biggest pro for the Docker is that whatever you do inside of these containers, you can just delete them. If you do something wrong on your local machine, it can lead to the deleting everything on the operating system. If you are full of trying to fix it, you can end up formatting operating system and installing again. With Docker, you can play around in containers how much you like. You can't ruin everything, ruin anything.
Can the configuration part be replaced with script, which will do the download and configure all dependencies for us?
Configuration part, I'm not sure which configuration part, because we dealt with a lot of configuration parts, Docker file, Docker compose. I'm not sure if that person can clarify either, or they want them to be unmuted so they can ask the question. I don't know.
So Alyssa, would you kindly write in general? Okay, in general, the Docker compose.
So can you repeat the whole question, please?
Of course. So can the configuration part, Docker composed, be replaced with script, which will do the download and configure all dependencies for us?
It does that. Basically, here, when we specify this, let me show you. So now if I Docker Compose pipeline, I have Selenium Hub locally, I have Chrome locally, but let me delete all of it. So I can go docker system prune a. This will delete everything from the Docker I have. Yes, I want. Yes. Okay, so now it's deleting everything. Let's see how much. So 2.3 gigabytes. So if I say now docker compose, let me not rewrite, let me see where's the command. Okay, docker compose hub, it's fine. Now it's going to download everything. It needs to pull Selenium hub from the Docker hub, because the Docker hub is like a repository. For example, if you are using NuGet uh, for .NET Core or .NET, you have to download those NuGets from somewhere. You have nuget.org. If you are using JavaScript, Node.js, you have npm. The same goes with Docker. Everything you try to use some image, it will look if there is image locally. If there is no that image locally, then it will download that image. So this is kind of already enough automated. I don't know if we can go any further to automate any further. And here also, if this doesn't exist, it's going to download it. So now you can see it's downloading a bunch of stuff for me automatically with only one command. Maybe you didn't get the right idea because all of these were already existing on my computer. So I didn't have to download them before. I just ran the same command before. So now when I ran again, these things didn't need to be downloaded again because I have them locally. So that's the only difference. And when it comes to downloading from the NuGet, here when I said restore, restore does the same thing for .NET Core. Basically, it downloads all the NuGet packages related to these, and it does that from the inside of the container. It downloads from the nuget.org all the ones. So for example, in demo tests CS proj, what do I have there? I have Microsoft.NET SDK, Visual Studio, Azure Containers Tools, NUnit, NUnit 3 adapter. It needs to download all of these. So everything is automatic.
Thank you very much. Another question which I would like to ask you is, we saw that you were using Azure DevOps as a platform. Do you have any recommendations? Is it better to use Azure DevOps or AVS or any other platform in that matter for this specific example, let's say?
I mean, for this is specific example, since you have seen me using Azure DevOps, it's if you didn't use any other, it's probably good to start with it since you have seen how it is used, and they are giving this free trial that you can use. The other platform that I used and I can recommend is GitLab, which gives you free for life usage, but there is no this fancy UI for creating pipeline. Here, you can create these jobs and it will generate you that file. Let me see where it is. Yeah, Azure Pipelines YAML file, which is going to be included in your project. For GitLab, it's the same principle. It's only a different name, gitlab-ci.yaml. For AVS, same, just different name of the file. I mean, the syntax is not the same. The syntax is specific to the cloud provider that you are using. But I know about GitLab that they are offering free versions. And the only drawback is that you need to have to configure more things manually. And it's these runners for running the test, building everything are a lot slower because they are shared among all free users. So my recommendation might be to start with something that is free and then go to something that is paid. And if you are a student, Azure is great. AVS gives even more. I have AVS subscription as well. It gives you 12 months like trial, and some of the things are for 1 month, some of the things are for a certain amount, but a lot of things are for 12 months. So when it comes to accessibility, if you're a student, use Azure. if you want to play around, you can use GitLab or AVS. For Google Cloud, to be honest, I haven't used it. Last time I opened it was maybe when I was a student, so I can't say a lot about it.
Okay, thank you very much. I can see that there are no more questions for you today. I would like actually to thank you for this lovely overview in front of system verification. And I would like to thank everyone who were included in this webinar and everyone who participated. I hope this session helped you out. Of course, we will share the recording to all the participants afterwards. And I wish you all the success, of course, Emir, and everyone else. So thank you, everyone, and
Thanks
have a
from
nice
me.
day.
Thanks from me as well. And if you find that you have some questions, you can uh, drop me a message on LinkedIn, on GitHub, or anywhere you can find me. So I'm eager to help any of you if you need help. Thank you again for participating.